mammoth is the most famous and iconic animal of the Ice Age. And for almost 2 million years, it dominated the ecosystems that are now temperate forests and Arctic tundra across the northern hemisphere. These animals existed during 98% of human history, and their last population vanished only about 4,000 years ago, when the pyramids of Egypt had already been standing for almost 600 years. In other words, there were humans writing, building monuments, and telling stories, while there were still mammoths living on remote Arctic islands. Today, a company has already raised several $1 million in funding to try to bring this animal back, and even the CIA has invested money in the project. The company is the Dallas-based biotech startup Colossal. Its goal is to de-extinct not only the woolly mammoth, but also the thylacine, or Tasmanian tiger, and the dodo, a giant pigeon from Mauritius that went extinct around 1690 due to human hunting and invasive species. In practice, they wouldn't be perfect copies, but hybrids very close genetically to the original species, created using gene editing and assisted reproduction techniques. And I already know what you're thinking, that these de-extinction projects are doomed to fail, and that De-Extinction, playing God with animals, almost never ends well. But maybe this video will change your mind. The idea isn't to create mammoths to lock them up in zoos or use them as a spectacle to make eccentric millionaires even richer. The plan is for them to become a key piece in preventing climate collapse. It sounds like science fiction, but it's based on real ecological processes that mammoths already carried out in the past. That's because one of the most fascinating ecological and scientific experiments in the world needs mammoths: Pleistocene Park. But how and why could the woolly mammoth help fight global warming? Is it really possible to resurrect an extinct species? Will we live to see a population of mammoths roaming free in our lifetime? Today we're going to answer these and many other questions. Right now, there are only 2 living species of elephants: the African elephant and the Asian elephant. Within the evolutionary tree of elephants, those two are already quite far apart. But in the past, the family was much more diverse. Today, elephants live in Africa, India, and some regions of Oceania. But not so long ago, they inhabited almost every continent except Australia and Antarctica. They are the last representatives of the proboscideans, the group that includes elephants and close relatives like mammoths, mastodons, gomphotheres, stegodonts, dinotheres, and others. And if we ever forget how weird elephants are, their extinct relatives are there to remind us. Their outsized tusks, domed skulls, and hypersensitive trunks are not normal in the animal kingdom. They're the result of a very unusual evolutionary history. The truth is that many people think mammoths are just hairy elephants, and well, in a way that's true. Although they're different species, the woolly mammoth shares 99% of its DNA with the Asian elephant, its closest living relative. On top of that dense coat of fur, mammoths had other adaptations to the cold, like a thick layer of fat under the skin and small ears to reduce heat loss. They probably also had a circulatory system adapted to keep their limbs and trunk warm, and blood with special properties to function well below freezing. The genetic differences between woolly mammoths and Asian elephants are small, but they include key adaptations for living in sub-zero conditions. Without those special features, Asian elephants would suffer terribly in the cold and wouldn't survive. Those are exactly the small differences, spread across hundreds of genes, that scientists want to copy and switch back on in the genome of modern elephants, to create something that, if everything goes well, is similar enough to a mammoth to walk on snow again. And, believe it or not, there were several species of mammoths. But here we're talking about the most common and successful one, Mammothus primigenius, the woolly mammoth. We know this species very well thanks to thousands of fossils, footprints, and even frozen bodies preserved in ice. All of that allows us to know quite a lot about what they were like in life. How big they were, what they ate, what diseases they suffered, and even how old they were when they died. For example, we know their fur had two layers, one shorter and another very long one. The color of that hair could range from blonde to reddish to black. Their name, woolly mammoth, comes from that extremely dense coat. Underneath that permanent scarf, they also had a thick layer of fat and skin, adapted to the icy winds of the steppe. Their curved tusks could exceed 4 meters in length and were used to sweep away snow in search of grasses and small plants. These animals lived in a vast frozen savanna that covered much of the temperate zones of the northern hemisphere, from Eurasia to North America. Back then, Siberia and Alaska were connected by a land bridge, which allowed mammoths to cross from one continent to the other. Around 26,000 years ago, during the last glacial maximum, Earth was colder and drier than it is today. Arctic glaciers covered a much larger area and made almost the entire region uninhabitable. Strange as it may sound, we call a glaciation, or ice age, any period in which Earth has a cryosphere, that is, permanent ice at the poles. This means that, geologically speaking, right now we are still in an ice age, or more precisely, in an interglacial period, a warmer phase within that ice age. Interglacial periods are relatively short moments, lasting tens of thousands of years, in which Earth becomes warmer and wetter than during the long phases of intense glaciation. The last interglacial began about 12,000 years ago and marked the end of the Pleistocene and the beginning of the Holocene. During the last glaciation, something very interesting happened. Areas that today are temperate coniferous forests were as cold as modern boreal ecosystems like tundra and taiga. However, despite the lower temperatures, those regions still received the same amount of sunlight, which allowed high plant productivity and strong vegetation growth, a perfect situation for huge herds of herbivores. At that time, these were the largest and most productive grasslands on the planet. That now vanished ecosystem is what we call the Mammoth Steppe. Many people blame climate change for the collapse of these steppes, but we know that Earth went through other interglacial periods even warmer than the present one, without destroying this ecosystem. What most likely transformed the most productive and diverse savanna on Earth into a more uniform, species-poor forest was the extinction of the megafauna. Plants and animals depend on each other, and in particular, giant animals play a crucial role in keeping grassland landscapes open. They uproot young trees, trample the soil, spread seeds, and recycle nutrients. The very rapid disappearance of so many species in such a short period of time may be related to humans, who arrived in those regions armed with spears, fire, and intelligence, and changed forever the balance between vegetation and large herbivores. The fact is that back then mammoths were so abundant that their bones were literally used as building materials. Not long ago, a temple from the Ice Age was discovered near the Russian city of Voronezh, built with the bones of about 60 mammoths. It's about 25,000 years old. These circular temples made of mammoth bones are not rare. It seems this practice lasted for thousands of years. It wasn't just about using bones that were lying around everywhere, but about raising complex structures with walls of skulls, jaws, and tusks carefully arranged. It's very likely that these places had ritual significance, perhaps as sanctuaries or monuments in honor of mammoths, or something important to those people. They may have been spaces for ceremonies, communal feasts, or storytelling around the fire, where the central animal of their daily life, the mammoth, was also central to their symbolic world. It's possible that mammoths also played a spiritual role in the lives of those communities. Maybe they were seen as lords of the snow or protective spirits of the hunt. We also have plenty of evidence that human hunting was a key factor in their extinction, such as bones with clear-cut marks from stone tools. For those people, mammoths were food, hide, fat, and probably also beings to be respected. A single animal could provide meat for weeks, bone for tools and shelters, sinew for cords, and fat to burn as fuel. The last mammoths lived on Wrangel Island, off the coast of Siberia, and survived until around 2000 BCE. That's so recent that they were still alive after the pyramids of Egypt had already been built. Considering that humans left Africa about 100,000 years ago, that means humans and mammoths coexisted in Eurasia for at least 90,000 years. They weren't just extras in the scenery. We shared almost our entire history with them. For example, an archaeological find in Toltepec, Mexico, helps us imagine what those interactions were like around 15,000 years ago. There, 2 large pits were found, about 25 meters in diameter and 1.7 meters deep. And inside them, more than 800 bones belonging to at least 14 mammoths. The most accepted idea is that this was a trap. Humans probably used fire to scare mammoths and drive them into the pits, where they could no longer escape. That implies planning, cooperation, and a very detailed understanding of the behavior of these giants. This discovery is important because it shows a direct interaction between humans and mammoths. Even so, we can't say that human hunting was the only cause of mammoth extinction, but we know we were one of the factors, and perhaps one of the most important. So the question is, do we owe them something? Now let's look at some of the best preserved mammoths we know. The first is the so-called Adams mammoth, discovered in 1799 by hunter Ossip Shumachow. It was the most complete mammoth found up to that time. The entire skeleton was recovered, along with pieces of skin from the head and more than 18 kilos of hair. As one of the first extinct animals to be reconstructed and displayed to the public, it has enormous historical and cultural importance. At the end of the 18th century, seeing that gigantic body emerge from the ice was almost like coming face to face with a real-life dragon. From its tusks and remains, the first attempts were made to imagine what a mammoth actually looked like. It was excavated slowly, at a time when the concept of extinction was still new. People debated whether the Adams beast was an elephant, and if so, what it was doing in a place as cold as Siberia. That frozen animal forced science to accept an uncomfortable idea: that Earth had hosted earlier worlds, full of creatures that no longer exist. Some suggested they were elephants brought there and buried by Noah's flood, but soon after, Georges Cuvier, considered the father of paleontology, argued convincingly that it was a species of elephant adapted to the cold that had already gone extinct. His great contribution was to break with the notion that all species ever created still existed, and to show that Earth had hosted completely different faunas in the past that had disappeared forever. Thanks to Georges Cuvier's work, the mammoth and the giant ground sloths became the first animals to be recognized as truly, demonstrably extinct, long before the word dinosaur even existed. It was a genuine intellectual revolution. For the first time, humanity had to accept that the world had not always been the way it is now. Much later, in 2010, a mummy called Yucca was discovered in Siberia, preserving skin over almost the entire body, patches of hair, and even some internal organs. This young female was first seen by local Yukagir people, hence her name, and is considered the most complete woolly mammoth ever found. Although she looks dry and desiccated, Yuka gives us an almost perfect idea of what these animals were like in life. She weighed around 5 tons, measured about 3 meters in length, and lived around 40,000 years ago. What's more, important parts of her DNA are still preserved, making her a kind of genetic library from the Pleistocene. Another famous specimen is the Jarkov mammoth, also found whole in Siberia inside a 23-ton block of ice. It became popular on the internet thanks to the mammoth in an ice cube memes. Jokes aside, finds like this allow researchers to study extremely fine details: stomach contents, tooth wear, bone injuries. Lyuba, another well-known mummy, was also found in Siberia on the Yamal Peninsula in 2007. She was a female calf. While she was exposed on the surface, some dogs chewed parts of her ears and tail. But aside from that, her preservation is almost perfect. Thanks to her condition, researchers were even able to determine the cause of death: suffocation by mud that became stuck in her trunk, mouth, and throat as she struggled to get out, about 42,000 years ago. It's a tragic end, but scientifically valuable. It shows the everyday dangers of life on the mammoth steppe. And now the big question appears: who exactly would be responsible for bringing the mammoth back? And for what purpose? According to the BBC, woolly mammoths could walk the earth again if a group of scientists and entrepreneurs gets its way. They have already received $15 million from investors. That money, destined for the company Colossal, will help develop genetic engineering technologies to create a hybrid between a woolly mammoth and an Asian elephant, as close as possible to the mammoths that roamed in the past. Once this goal is achieved, the next step would be to repopulate parts of Siberia with these animals to try to restore environmental balance. In other words, all that money will not be used just to bring the mammoth back, but will also fund a lot of research in genetic engineering that will be useful for mammoth cloning and could also have important medical applications, such as cloning organs and tissues for transplants. The economic interest in the new techniques developed along the way is enormous. Whoever masters these tools will not only have the recipe to create a pseudo-mammoth, but also key technologies for the medicine of the future, for conserving threatened species, and of course, for new biotech businesses. It's a line of research that attracts a lot of attention and, above all, a lot of investment when it's presented seriously. George Church is a biologist at Harvard Medical School in the United States. He proposed the idea of resurrecting mammoths in 2013, and from then on, spent more than 8 years trying to find investors to make it a reality. It wasn't just a quirky idea. Church has spent decades working on genomes, gene editing, and synthetic biology. So for him, mammoths were both a technical challenge and a large-scale ecological experiment. For him, the obvious starting point is the already sequenced DNA of woolly mammoths. But even if the idea was good, there were 2 major problems: money and technology. This is a line of research that's heavily debated from an ethical point of view. So at the beginning, it was hard to get the money needed to make it work. What does it really mean to create animals that no longer exist? Under what conditions would they live? Who would be responsible for their welfare? On top of that, this is a very innovative and ambitious project. But it's also extremely expensive. Before attempting to bring back the mammoth, a lot of basic research was needed just to refine the methods. Not only in embryology, but also on the ecological and climatic effects of returning this species to the world. It would be necessary to understand how to gestate a mammoth-elephant hybrid, how to raise it, what it would eat, how it would behave in extreme cold, and what impact it would have on other living beings. In other words, An entire ecosystem of research and technological development had to be created to make the project viable and to understand its limits and its possible consequences. According to the BBC, at first Church's ideas attracted journalists, but not investors. He had only managed to raise about $100,000 for his research. He even said he expected to work at a slow pace. But in 2019, he met Ben Lamb, founder of the Texas AI company Hypergiant, who read about the project and became interested in helping to rescue this giant animal. Lamb brought something as important as scientific talent, the ability to turn a lab idea into a startup that big funds would find attractive. That was when the biotech company Ecology was born. According to the company itself, we've reached a point where this is not only possible, but also necessary. And the mammoth is not the only animal in their de-extinction plans. They also want to bring back another animal, the Tasmanian tiger, or thylacine. This animal went extinct in the wild around 1920, and the last captive individual died in 1936, less than 100 years ago. But despite its name, it was nothing like a wolf. It was a carnivorous marsupial that lived only in Australia and Tasmania. It was more closely related to kangaroos, koalas, and Tasmanian devils than to any placental mammal like wolves. Bringing it back would not only have huge symbolic impact, but would also serve as a test of how far our ability to repair, at least partially, the damage we've done to other living beings can go. Marsupials have a very short gestation. The baby is born extremely small and fragile, and then crawls into the mother's pouch. Inside the pouch, it finds the teats, latches on, and continues to grow there until there's no more room. Placental mammals, on the other hand, usually have long and costly pregnancies, and the young are born more developed and relatively independent. That makes their biology very different, from the shape of the womb to the way babies are shed and cared for. That means a wolf is more closely related, evolutionarily speaking, to any placental mammal such as cats, rabbits, or elephants, than to a thylacine. Even so, the similarities between wolves and thylacines are a classic example of convergent evolution. Starting from a generalist ancestor, both placental mammals and marsupials separately evolved a dog-style predator, an elongated body, strong legs, teeth adapted for cutting meat, and hunting behavior either in groups or alone. Thylacines were the top predators in the ecosystems of Australia and Tasmania until relatively recently. Their absence has caused serious ecological problems. Without a predator to naturally control herbivore populations, their numbers can grow too much, to the point where the ecosystem can no longer support them. That greatly reduces vegetation and makes the environment more vulnerable to fires and famines. When top predators disappear, ecosystems suffer a trophic cascade, a chain reaction that negatively affects the whole environment, from plants to insects and birds. According to Ecology, humans have a responsibility not only to bring the thylacine back, but also to reintroduce it into its former habitat until ecosystems recover. That could help reduce plagues, fires, and droughts. All of this sounds good on paper. In reality, it's far from clear that cloning a thylacine using the womb of a donard, a small marsupial, is feasible, or that its reintroduction into the wild would bring fast benefits. There are doubts about whether the current habitat is still suitable, and about how the species that now occupy its niche would react. Today, the main large predators in Australia are dingoes, wild dogs whose populations are themselves quite fragile. They are not domestic dogs, but descendants of dogs that arrived with Aboriginal peoples more than 4,000 years ago. Since then, they have readapted to wildlife. Their arrival is considered one of the main causes of the thylacines extinction, although government extermination policies finished the job. According to Colossal, in 1888, the Tasmanian Parliament established an official bounty of £1 per thylacine, according to the Tasmania Parks and Wildlife Service. These rewards encouraged more lethal methods to control the thylacine problem, and, as hunting increased, their numbers fell rapidly. In July 1936, the Australian government declared the species protected. But that change of opinion and awareness came too late. On September 7, 1936, barely 2 months after receiving protected status, Benjamin, the last known thylacine, died from exposure in Beaumaris Zoo in Hobart. That story is exactly what many people want to avoid repeating. Colossal also talks about plans to de-extinct the dodo, but unlike the mammoth and the thylacine, there doesn't seem to be a particularly strong or clear reason to do it, so we won't go too deep into that. What's interesting is that the technology needed to clone an animal that hatches from eggs is very different. And announcing the return of a charismatic species like the dodo may partly be a very clever marketing strategy to attract funding. That money would then finance basic genetics research that, in the future, could generate a huge number of patents and profits. In other words, even if the dodo is the star on the poster, the real product is the technology developed along the way. In a recent interview with MIT Technology Review, Colossal's head of cloning said the company intends to clone the first thylacine in 2 years, in 2025, and the first mammoth in 2027. The main difference here is gestation time. Elephants take between 18 and 22 months to gestate, whereas marsupials, and especially the dunnart, which will be our surrogate species for the thylacine, take only 12 to 14 days. After that, they continue their development in the pouch. There are studies showing that marsupial young can move from the pouch of one species to another and still develop successfully. But we also have a team working on an exopouch, an artificial pouch where the young will be able to go and receive the same nutrition, the same environment, and the same light conditions they would have inside a marsupial mother's pouch. If this kind of technology worked, it wouldn't only be useful for thylacines. It could revolutionize captive breeding for many other threatened marsupials. But how, in practice, would it be possible to bring back the mammoth and the thylacine? Cloning placental mammals and marsupials requires very different gestation technologies, but the first step is the same. The idea is to use the closest living relative, in the mammoth's case, the Asian elephant, and change only the parts of the DNA that are different. That's much easier than trying to rebuild the entire mammoth genome from scratch. Seen this way, the result wouldn't be a pure mammoth, but a hybrid, something like a mammophant or an eel moth. According to CNN, Church has been one of the pioneers in the field of genomics, including the use of CRISPR, a revolutionary gene editing tool that allows scientists to rewrite life's code to change organisms' traits. His team analyzed the genomes of 23 species of living elephants and extinct mammoths. They believe they will need to make more than 50 simultaneous changes to the Asian elephant's DNA to give it the traits it needs to live and thrive in the Arctic. They also want to modify the animal so that it has no tusks, so it doesn't become a target for ivory poachers. The complete DNA of woolly mammoths was finished in 2015, based on 10 bodies found on Wrangel Island, the species' last refuge. If this project succeeds, it would be the first cloning of an ancient extinct animal, but not the first de-extinction in history. The first de-extincted animal only came back for 10 minutes. In its brief existence, it already showed us both the potential and the limits of this technology. And it opened a debate that the mammoth and the thylacine are now taking to a much bigger scale. We're talking about the bucardo, a type of Spanish wild goat. It was the first animal to be brought back after having gone extinct. The last bucardo died in the year 2000, but its cells were preserved frozen in liquid nitrogen. In 2003, researchers managed to clone a bucardo kid, but it lived only 10 minutes. That was enough to prove that de-extinction was technically possible, and also to show how fragile and limited this technology is. Today there are plans to de-extinct it again. It's an animal that has already gone extinct twice. So the bucardo's story goes something like this. It appeared, went extinct, was de-extincted for 10 minutes, went extinct again, and now people want to re-de-extinct it. Until one day, it goes extinct for a third time. It's like an animal that can't quite rest in peace. But it also raises an uncomfortable question. To what extent does it make sense to bring back a species if we're not able to guarantee it a stable future? And with mammoths, a big problem arises. If we manage to clone large numbers of them, where are they going to be gestated? There are two possible options, and neither is simple. The first option is to use the wombs of living female elephants, which could involve a certain degree of cruelty and exploitation, something Church himself acknowledges. We're talking about extremely long pregnancies, difficult births, and physical and emotional risks for animals that are already threatened in the wild. The second, more expensive option would be to use artificial wombs to develop the embryos from scratch. That technology already exists, but it is still far from perfect and needs much more research and time before it can be considered truly effective. It isn't enough just to keep an embryo alive. You have to accurately reproduce the chemical, hormonal, and physical environment of the womb. Meanwhile, the permafrost is melting very quickly, and if this takes too long, it may be too late. That's why Asian elephant females are still, for now, the best candidates to be the mothers of these prehistoric hybrids. But why are some people so interested in mammoths? And how exactly are they supposed to help us slow the climate and ecological crisis? If there is anyone in the world who truly needs a mammoth, it's Sergei Zimov and his son Nikita. In Russia, they are trying to recreate the Ice Age ecosystem by introducing thousands of herbivores that transform forests into grasslands. They call this experiment Pleistocene Park. They're doing all this to slow down the thawing of permafrost, a problem we should all be a lot more worried about. Permafrost is soil that remains permanently frozen and can reach depths of tens of meters. It forms when layers of grass accumulate on top of each other and freeze before they decompose. In this way, the ground pulls carbon out of the atmosphere and stores it as frozen organic matter. It's like a giant natural freezer spread across the Arctic. The problem is that when permafrost thaws, that organic matter rots and releases huge amounts of CO2 and methane into the atmosphere. Exactly the gases that cause global warming, which melts more permafrost, which releases more gases, which warms the planet even more, forming a vicious cycle that can destabilize Earth's entire climate. Today it's estimated that around 1 trillion tons of greenhouse gases are locked up in permafrost. If a significant portion of that sleeping monster is released, all our efforts to reduce emissions might not be enough. And this is where, according to some scientists, a herd of mammoths could start to matter. To give you a sense of scale, that's more than twice the amount of carbon stored in all the world's forests. Permafrost is like a climate time bomb, and we may be running out of time. According to Sputnik, the project's goal is to replace modern low-productivity ecosystems with highly productive grasslands, with a fast biological cycle and greater animal diversity. The first animal reintroductions began in 1988. Currently, the park has a fenced area of 20 kilometers and is home to 9 species of large herbivores. But how does the presence of megafauna help keep the soil frozen? Before it collapsed, the Mammoth steppe was the largest terrestrial biome in the world. It covered much of North America, Europe, and Asia, in areas that today have temperate forests. These pine forests have low biodiversity because almost no animals can feed efficiently on their needles. However, until about 10,000 years ago, the situation was very different. Large animals trample the ground, destroy tree saplings, push down young trees, and open up space for grasses to grow. And grass, unlike the tough leaves of pines, is the ideal food for many herbivores. The more grass, the more herbivores. And the more herbivores, the more they keep the landscape open as grassland and encourage even more grass to grow. It's a virtuous circle between plants and animals. In summer, grass grows very quickly and captures carbon from the atmosphere in its biomass. In winter, part of that grass dies and freezes instead of decomposing. Then a new layer of grass grows over that compacted organic layer, storing carbon as frozen, packed organic matter. That collaborative relationship between plants and large animals was broken when megafauna went extinct. And since then, forests have grown and turned into a kind of vast green desert. Lots of trees, but low diversity and little ecological interaction. Precisely because this system is so good at trapping carbon from the atmosphere, it turns into a climate bomb when it melts and all that material begins to decompose. That's why an idea as seemingly crazy as Pleistocene Park could actually work. The proposal is to use animals as ecosystem engineers. So how does that help slow the thawing of frozen ground? Odd as it sounds, snow is an excellent thermal insulator. Each winter, several meters of snow accumulate on top of permafrost. That layer prevents the cold air from penetrating the soil and stops it from freezing very deeply. While the air temperature can drop to 40 degrees Celsius, the ground under the snow can stay around 5 degrees Celsius, protected by that insulating blanket. But when animals walk on the snow, dig through it and break it apart in search of food, they destroy that insulating layer and allow the soil to freeze more, which delays thawing in the summer. With enough large animals disturbing the snow every winter, the cold penetrates deeper and the permafrost stays stable for longer. As Nikita Zimov puts it, there are two ways to reduce the insulating effect of snow. Either we drive a bulldozer across the entire Arctic, or we let the animals do the job. And let's be honest, it's much cheaper, more sustainable, and more logical to let millions of hooves do what they've already been doing for thousands of years. Soil that remains insulated under a thick snow layer melts quickly when summer comes. In contrast, soil compacted by animals stays frozen more permanently and is much less vulnerable to thawing. By breaking up the snow, herbivores inject winter cold into the deep soil layers, as if they were driving millions of tiny ice needles into it each year. The experiments at Pleistocene Park began back in Soviet times with the introduction of wild horses. Horses were an excellent first choice because in the past they were among the most common animals in that region. Within a few years, the horse population was large enough to maintain and grow on its own. Together with bison, reindeer, and muskoxen, they began slowly transforming the landscape, opening clearings, breaking up the soil, and encouraging the growth of grass. There is still a lot of tree felling to do to make space for grass, because smaller animals can't knock down large trunks. That's where the mammoth comes in. In the African savanna, it's common to see elephants pushing trees over to reach the leaves more easily. And often they seem to topple them just because, for no clear reason. That behavior, unintentionally, ensures that future generations will still have grasslands to feed on. Mammoths, or their hybrids, could play the same role in the modern tundra. The project's idea is to reintroduce mammoths into the park. They would be a key piece in rebuilding the ancient ecosystem, which could help us avoid a catastrophic global warming scenario. Mammoths would be responsible for knocking down big trees, trampling the snow, and producing huge amounts of dung, heavily fertilizing the grasslands. Sergey and Nikita's plan is that, with the right animals, the ecosystem could grow and expand on its own. If that were to happen, it could become a very powerful force for slowing the collapse of permafrost and even gradually refreezing some severely affected areas. And without mammoths opening up grassland clearings in the forest, that ecosystem might not be able to sustain itself in the long term. Permafrost thaw and the decomposition of its organic matter cause serious environmental damage. Craters can form when the pressure of gases trapped underground becomes so strong that the soil explodes like a small methane volcano. Large landslides occur because ground that used to be very stable when frozen becomes unstable as it thaws. The released water can form lakes that accelerate decomposition even more. Villages and cities built on permafrost are at high risk of sinking. To make matters worse, once the soil starts to decompose, biological activity is so intense that the ground warms itself, causing even more melting. It's a self-reinforcing process. And precisely for that reason, any tool, like a herd of mammoths, that might slow it down, deserves very serious study. However, there may come a point when not even all the animals in the world together could fix this problem. This is one of the so-called climate tipping points. Imagine Earth's climate is like a chair. You can tilt it a bit and then put it back. But if you tilt it too far, it falls and stays in a new stable position. The climate works in a similar way. Once a certain limit is crossed, it doesn't return to its previous state. We know this has already happened several times in the planet's history, usually during periods associated with mass extinctions and deep changes in life. So there's some irony in the fact that the mammoth mummies we're finding, and that help us understand what's happening to the climate today, are only appearing because their icy tomb is melting. Who would have thought a mammoth could turn out to be so necessary? Extinction is a special kind of death, a greater death. It's a law of nature that had always been respected, until now, when humans have begun to develop the ability to break it. As de-extinction research advances, many people criticize these projects, highlighting the irresponsibility of bringing back extinct animals without fully understanding the consequences, and also condemning the potential cruelty of the methods used. Even so, in the mammoth's case, as incredible as it sounds, it might actually be a matter of necessity. As Sergey says, for a long time, humans saw wild animals as dangerous enemies. And now that we understand they're part of the ecosystem, we need them. So there is a real possibility that in the coming years, we could see living mammoths helping to transform boreal forest into rich grassland filled with millions of herbivores. It's only natural that many people criticize this and say, quite rightly, that it may be more of a business opportunity than a serious environmental action. Would we be able to create mammoth herds fast enough to genuinely slow or reverse permafrost thaw? Or would the opposite happen? That populations would grow so slowly that in practice, they wouldn't make much difference. Up to now, we've talked about cloning a mammoth, but in reality, we'd need tens of thousands of them, at the very least, to produce the intended effect. If the process is too slow, we'll have to think about more immediate solutions than mammoths, fascinating as they are. We also don't know whether those populations would be truly viable or how they would change the environment. Their impacts could be unpredictable and might even cause huge ecological and economic damage. So, Wouldn't it be better to invest that money in protecting species that haven't gone extinct yet? Or are we being too conservative by thinking that way and giving up on a potentially powerful tool to defend nature? There are many open questions, and the answers we give in our time will shape the future of life on Earth forever. Should we give a second chance to species that have already been lost or not? In any case, this possibility is already real and isn't going away. If we look at history, it's only very recently that we discovered what DNA is. And genetic engineering and cloning techniques are advancing faster and faster. With the help of artificial intelligences that edit genes, processes that used to take months could be done in a matter of hours. What will we do with all this potential? That's a decision our generation will have to make, and it won't be easy. We must also be careful not to resurrect dangerous ideas from the past, such as theories of biological superiority. The same technology could create a world where wealthy people can freely edit the traits of their children, causing a split between natural people and genetically designed people. But it could also be a revolutionary tool against cancer, degenerative diseases, and many genetic conditions that might eventually be prevented. Cloning and de-extinction will almost certainly remain very tempting options in the fight against climate change. That's why it's important that we talk about them. Tell me in the comments whether you're for or against de-extinction. And if you enjoyed this video, send it to someone who might find it interesting. You can also consider becoming a member of the channel. Thank you so much for making it all the way to the end. And may you have a wonderful life.